For our last video today, I want to talk about how Java really works when you call a method with an argument and it's received by a parameter. And to do that, we have to look at a little bit more in depth of how all these things are stored on the computer. And then this has some subtle ramifications for what happens when we're using arrays as these arguments and parameters and methods. So again, instead of just sort of saying we pass a value, a little more formal understanding of this, and we're going to learn about some parts of computer memory called the stack and a heap, and how that all relates to variables and primitives and objects and things like that. All right, so here's some code. We have a method, add to count, and we have a variable down in main that we pass to this add to count. And the question is, what exactly would this do, right? So we create count as 1, we print it out just to see what value is stored inside count. We call add to count, where this count equals count plus 1, and then we print it out again. So take a second to think about what you think is going to print both places, and when I run it, it's the same. So nothing really happened here. And now we need to understand why that's true. So first of all, remember from scoping rules, this count belongs in this scope, this count belongs in this count, and those are really two different things, right? Two different variables. They have the same name, but they're in different scopes, sequential scopes. The other thing to remember is that when we call a method, we're not really passing this variable to here. We are taking the value of whatever expression is here. In this case, the expression is just the value stored in this count variable. So we take the 1, and we use that 1 to initialize this variable count here. We add 1 to count and store it in this parameter count. We leave scope. This count goes away, and we end up with the same count as before, and we print it out. If I wanted this value to come out of here, we should return count plus 1, right? And then we'd make this an int method that returns a value, and would assign the result of calling add to count back into another variable like count. All right, so how does all this work? So, again, having count as two different places is sort of a coincidence. Probably a bad idea a little bit, but not a syntactical issue. Again, when a method is called, we evaluate the arguments and pass the value of that expression to initialize the parameters in the method, right? And that's just really, if you know that, you're in pretty good shape, I'll have to say. So how does this really work on a computer? Well, Java keeps track of variables and their locations in memory. So again, your computer memory is a whole bunch of places to store data. And really, when you make a variable called like count, that is just Java's way of naming one of those locations in the computer, so it's easier to access, right? Variables are created on a part of memory called the stack. And the stack is an area that has certain properties we'll talk about. But basically, when you make a new variable, it adds to the end of the stack. And when you leave a scope, there's sort of a bunch of variables that were defined in that scope that are removed from the stack. And as we go through code, it's worthwhile to sort of understand how we're adding and removing these variables from a stack. So let's try it with this code here. All right, so we start in main. That's where code executes. We declare. Now I'm going to call it num, just because this count thing was getting a little confusing, right? We declare a variable num and assign 1 to it. So you can kind of think of that again here on this, what we're thinking of as this stack is a variable num with a 1 associated with it. We call add 1 with whatever value this expression here is, and so that's a 1 that gets passed to x. When it sees this in this new scope here, it adds x onto the end of the stack and assigns it the value 1 from this argument from the argument. Then in the method, we add 1 to x, so x is changed to be 2. We leave the scope here, and the x is removed from the stack because it is no longer a valid variable name. And num remains, right? The original num. And we print it out, and that's 1. So again, we pass this value up here. This is called the pass by value parameter. And we change the parameter, which does not change, has anything to do with this, right? They're not connected. So first of all, it's the main thing, one thing to keep in mind. When I pass something up there, it doesn't change. I can return a value out of the method, which is how we're getting sort of changed values out, but just working with these parameters up here doesn't do anything to what called it. And that's great. It reduces complexity, right? We don't want things sort of changing without understanding why they change, and so it's a good way to just make sure things aren't happening without us expecting it. Okay, so that's like for the basic case with primitives as arguments and parameters here. It gets a little more complicated when we start doing things with objects like arrays. All right, so when we talk about primitives, a variable of a primitive type stores the value, and that's why in some ways this notation here works pretty well, right? You're just saying in num is this value. An object variable holds a reference to the object. All right, we're going to talk a little more about what references in a second, but it holds this location of where that object is, not the object itself. So let's make an array here, and we did this in the package video, but I'm going to sort of do more with it here. So we make vals equals 2, 5, 10. I'm just trying to make numbers that are distinct from their index, not 0. If you do 0, 1, 2, it's hard to tell what's the value and what's the index, but just make it clear there. And if I print this out, let's print out vals plus vals, and I run this. Again, I get this very strange thing, and basically what this is trying to say is that this is a reference. Well, I say it's related to where it's located in memory, right? It's actually something called like a hash ID, but this number you can imagine as being some location in computer memory. So computer memory all has addresses. So the first spot we can store something is address 0. The next spot is 0, 1. Next spot is 2, and so on. And there's sort of like an index into your computer memory. So, but it's this thing here is what's stored in vals, right? When you say print count, it prints out the actual value because that's what's stored in the location that vals is stored in the computer. What's stored in the vals variable is this reference of where this larger thing is actually in the computer. All right, so it's sort of it gets confusing because it's like another jump. You don't say count 1, you say vals, here's this object at this location, and then you go one other place and find it, and you can actually get values out. Okay, so again, computer memory is a bunch of places to store data. You can actually think of it kind of like a big array, so it has an index that says where in that computer memory to look. And a variable is just a name for that memory location, right? So Java basically tracks variable names as it's looking at your code. It tracks the type of value it holds, like if it's an int or an array, and it tracks the memory address where the variable stores its value. And that value is either a primitive or a reference, right? So yeah, let's print it out. Again, it's this strange thing that has some meaning, but hard for us to know much about. And as we looked in the first video, if you use arrays to string vals to print the whole thing, if you want to look at the arrays values. Okay, so how does it all work on the computer? Basically, again, variables are created on what's called the stack. It grows as you add variables and shrinks as you leave scopes. So it's very organized, right? So basically, if you have a method and you have a little scope inside it, and you add some more stuff, when you leave scope, you just have to look at the end to remove those things from the end. You don't have to search through the whole stack to figure out what goes away. It's always the stuff on the end. And that makes it very fast. Objects themselves, not primitives, but objects, are created on what's called the heap. And it's also just part of computer memory. Typically those two parts are sort of separated from each other. And in the heap, things can get added wherever there's space. So you get stuff with like holes in it and stuff, right? And the computer has to figure out where there's a big enough spot to hold the thing you want to build, like an array of 10 ints. It has to search through the heap and find a space that has a gap with 10 ints in it. As long as that object is no longer being used, it basically gets ready for garbage collection, and because it's considered garbage at that point. And basically at some point, Java spends some time sort of cleaning up its heap and saying, marking spots like, okay, this is no longer used, so we can free it up for someone else to use. And sometimes there's some shifting around to make the holes be more uniform and so on. So that's the kind of stuff, the stack and heap stuff, you get into a lot in more systems-oriented classes, but you really need to be aware of how this works, because it changes your understanding of how your programs run. So let's look at a kind of simple example, but it's going to be complicated enough, okay? So here is some fake memory for the computer, and it has an address and a value that's stored in it. And here is what the Java compiler is looking at that says, here's a variable I know about, and here is the type of it and where it's stored. And here's just 2 lines of code. We're going to make a primitive, and then we're going to make an array. All right, so when we execute this line here, declaring num, first of all, the compiler says, okay, we need a variable named num. It's type int, and it's going to find a location on the stack. And I'm just going to use, it's not really this location address 1000 normally, but I'm just trying to pick a number that seems easy to start with. And I also notice these addresses make jumps. That's because different size things take different amounts of space. And just for the purpose of just sort of working through this, we're going to basically say that everything takes the same amount of space, 4 spaces. But in this case, we're saying, okay, num is here at this location, and we're going to store a 3 in it. All right, so primitives are stored at the address that the variable is associated with. Next, we're going to declare a variable that is of an object type, an array type. And in this case, so num array, it's an int array. It is also created on the stack, right? All variables, when you declare them, are created on the stack. Just stick to that rule. It's easy to kind of decide you want to do something different, but there's no reason to. It's just build it on the stack. So we add to the end, and here is 1004 where this num array is. And the question is, what value is stored in here, right? Well, it's not the array itself, 2 ints with the 0 initialized. It is the location on the heap where this array gets built. So when it gets over here, we've declared this thing, and now what are we going to assign to it? New says, go make me an object on the heap somewhere. So we make something with space for 2 ints. And again, this is sort of random, right? It's just wherever the computer decides there's a space big enough in the heap space to hold these things. New is an operator, and it returns this reference of where this thing is. So where does it start? It starts at address 1020, and we're going to store that 1020 here as the value for num array. And this is really the reference here, right? Now, really, in reality, there's multiple layers where, again, we're not really directly dealing with memory addresses in Java, but it's okay in some ways to kind of think of it as something like that. Okay, so notice the difference here. The primitive stores at the address of the variable that value. The array variable, which is an object type, stores some location of where the array really is in memory. Okay? And again, so there's nothing different. It's just that what gets stored, some location. When we leave scope, those variables go away. They're removed from the stack. And at some point during garbage collection, Java realizes there's nothing referencing this object anymore. In other words, we can't even get to it because the variable that knew about it has gone away. And it also removes it from the heap. All right, but it's a little undefined when exactly that happens. So this process of writing down this table of where my cursor going here? Cursor, hello. Writing down the variables we know about, their type and their address, and building up a little pretend stack and a little heap is very valuable for understanding how programs actually run. And we need to practice that as we keep learning about new things. Okay, so here's why we went through all this process. What happens when I assign one object to another, one object variable to another object variable? All right, so here I declare vals. It's a new int somewhere. Again, what is stored in vals? It is a reference. Here I make a other array variable declared, and I assign to it whatever is stored in vals. Well, what is stored in vals is a reference. So other has the same reference at this point as vals, which means if you ask other to go to its array, it's really looking at the same array that vals is, right? I didn't really make a whole separate array doing this. I told them to just share the same object. And so you can kind of think of this again as here's the two variables, and they both reference or sort of point to this object somewhere else. Which means when I change other, put a 5 up here, right? It went from default initialized 0 to 5. If I were to ask vals at index 1 what its value is, it would also say 5, because they're both looking at the same array, right? They're the same object. So unlike primitives, when we assign one primitive to the other, it says what value is stored in, like x, for example, 1. It puts that 1 and assigns it to other. Those are not linked together in any way. They just share that value. Here, with objects, again, they share a value, but the value is the reference to that object, which means that any changes to the object through one changes it through the other. All right. And there's a way to make it like what's called a deep copy of objects, and so you can create a new object that's a copy, but you don't do it just through assignment. Now, what happens if we try to call a method within an array? Now, this is sort of like our add one with count, where it didn't change, but in this case, let's see what happens here. So let's, I'll just start writing, I guess, here. Public static void, so it also doesn't return a value. I'm going to say add to array, maybe. And up here, I'm going to make an int array. I'm going to call it array. And in there, I'm going to say take array 0 and add to it 1. All right, so this is whatever value stored in the 0 index of array, we're going to add 1 to it. And I don't want all this stuff anymore. Okay, here we have vals as an array, and I'm going to add to array and pass vals to it. And I'm going to print out the toString of vals here. And I need to import, arrays, I think, right? Arrays to string. Oops, come on, give me the quick fix. Okay, happy. And I'm going to copy this and print out vals. So vals before we call add to array and vals after we call it. And if I run it, so it starts off 2510. And then I added 1 to the 0 location in the array, and we get back 3510. So notice this is a different behavior than when we called add to count. It didn't change count, the thing we passed up to it, right? it was just temporarily changed in here. Here, this change persists outside of the method. So the question is, why did that happen? All right, so this is where all this reference stuff comes important. So we start in main, we have vals. We call add to array with vals, which means this array variable has the same reference as vals, right? And so they're both looking at the same array. We change array 0, we add 1 to it. When we leave this scope, this variable goes away. We return to where we called it. But at this point, vals is still looking at this same array, and it has the changed value. It's 1 bigger. So this is a different behavior. Normally when we had a static void method, it could only do something like print something out to the screen. It couldn't have any action that persisted because any primitive stuff just goes away. But here, when we're passing a reference to here, this becomes a shallow copy of this original array. In other words, they are both looking at the same location in memory. When we change it here, it really is changing the same object that this reference is also looking at. And so it changes in this method. All right, so that's sort of a different behavior, but it's all based on the same idea. We are passing a value that's stored in this variable and using it to initialize this one. It just happens that when it's an object, we are passing a reference, which means they are looking at the same object. When we call with a primitive, we are passing the value as well. Both are passing values, but this one is a number value, and we're changing that locally, and then it doesn't persist after the fact. It is very important for you to kind of get this straight, and I understand that there's like a lot of little diagrams here. Go through these slides like 10 times. Try to make sure you're getting some understanding of what's going on here, and we'll review this some more. But what it means is that if you pass an array as an argument to a method that has that array parameter, basically the values stored inside the array can be changed. You can't assign a new array and have it persist, but you can change the value inside the array. Now we could sort of do the same thing with a string, except string has one other property. It's immutable, so you can't actually change the inside of the string. Otherwise, we could do that in a method as well. But as we start to learn about more objects, we'll see other ways to use this behavior. Okay, so maybe a lot to kind of get on track, but I think this will hopefully, it's important for you to have a detailed understanding of this process of calling methods with parameters and what exactly happens when we do that. So you have to get this solid.